Hello, welcome back. We are going to continue throwing dummy components into this assembly. So today we're starting with the crankshaft. So where we were so far. So we left with our piston, our rod, and our block, like this. And I'm going to put in so we need a crankshaft. We need something to convert this linear motion into rotational motion. So what I've done here is just made a dummy crankshaft. So basically what I did was, for the time being, we're assuming that our cylinder, our bore stroke, sorry, let me reset, our piston stroke is 80 millimeters. Well, if you imagine a crankshaft, that means that the crankshaft throw has to be 40, because when it's at the top of the rotation, it's 40 millimeters above the center line of the crank. And then when it swings down to the bottom, it's 40 millimeters below the center line. So 40 when it's on the top and 40 on the bottom equals 80. So I made two shafts, main shaft, and this will be our offset shaft. And then I snipped away what I didn't want, threw a plane in the center for reference, and then sketched in a counterweight. And this is not how this will look in the end, but it's how it's going to look right now. And so if I take this now, let's throw it into our assembly. All right. So let's constrain this to here. And then let's section some of this away so we can see. And let's constrain this to here. We want that little guy in there. And then for the time being, we need to kind of keep this from going all over the place. So just for now, I guess what I'll do is maybe just constrain that to that face. And now if we section this way, we should be able to kind of see what we're working with. Yeah, that looks right. Now, I can already see how just tiny this counterweight is going to have to be much larger to balance out the, what this counterweight is doing is, as this piston moves up and down, its mass is being accelerated and decelerated, causing a vibration, causing force. And so you counterweight down here on this side to balance that out. We can also see that my center line of my crankshaft needs to be moved down so that this top face of the piston is closer to the top face of the block. So let's just start messing with this. Let's make this 180. All right, that's closer. We'll leave it at that. And just based on previous crankshafts that I've seen, in reality, this is much larger. Like something, it might be something like, like this. And, what this makes you realize, first of all, is that this space below this cavity is going to have to be much wider than the top of the block. And you see that on inline diesel engines in reality. So how are we going to do that? Well, let's go to the block, and instead of doing what I did, let me take a note of where this is. It's about 180 millimeters from the top face. So let's just delete that. And we'll delete this feature. And what I'll do instead is something like this. We know that we're going to need more space. So for now, let's just do something quick and dirty to get more space. We don't know how much space we'll need or the best way to create this for like manufacturing purposes, but that's way down the line. Sure, 15 sounds good. And we still need a center line that's 180 millimeters down to kind of give a place to lock this in. Lock the crankshaft in. So what if we just grab these lines and that and okay. Let's droop that in a bit. Now this should throw some errors because we've lost some constraints, and it does. So let's fix those. We'll change this to face with this face. Okay. And then we will delete that. Sure. Let's make this a little bigger too. All right. That's a start. Let's clean this up just a little bit. We'll make these collinear. And we'll make this I don't know, 30-degree angle. Make these parallel. Make that equal to that. Oh, there's an error here too. Let me make these. Let me fix that. Make these parallel. all of a sudden it starts to look like something here. Hey, sure. Great. Okay, so we have kind of a dummy. When I say dummy, I mean dummy parts, like placeholders until we can refine them. So what we also need is a head. And the head is the part that goes on top of the block that encloses the cylinder. And so what do we know about the head? Well, let's think here. So the head is on the top of the cylinder. We know we have to hold it onto the block somehow. So I have made a box that's the same size as the block, and I've put in 6 holes for head bolts. Why did I pick 6? Well, a lot of diesel engines have 6. Some have 4 with varying degrees of success, but 6 is a safe bet. And then I have to also decide how many valves are going to be on top of it. You can do 2 valves per cylinder, like I have here. I've showed 2 little circles. That is basically representing where the valve stems would pass through. The problem with having only 2 valves is, 1, you get less airflow, and 2, the actual valve itself is much larger than these stem holes. It'd be like this and like this, which means there's not a lot of meat in the metal left over to put your injector. And alternatively, you could do 4 valves per cylinder, which allows a lot more airflow, and it leaves the space in the center more clear to put the injector. But then you have to have more cams to actuate those valves, or you have to have some way to actuate them, if not with an additional cam. So for now, I'm sticking with 2 valves per cylinder, and we just extrude this out. So now we can bring that in. And we know it's going to go flush to that face. And we know that the center lines should match up. So like that plane should be aligned with that plane. Yep, that makes sense. We know that is this the plane I just did? I don't remember. No, it is. That plane should be aligned with that plane. All right, so now we have kind of a head. And I think that's where we're going to leave it for now. And next, we have months of work. Weeks just to get all the dummy parts in before you even start circling back to refine each one and make all the real critical decisions and all the critical calculations. But so where we'll leave off is we have a rough block, rod, crank, piston. Look, this thing's falling out. We got to work out how deep this is going to be. And then we have a head. The head we have to make room for the injector, all the valve springs, the valves, the intake port, the exhaust port, and then cooling, and just a ton of stuff. So we'll get there. But this is where we're stopping for now.